Hello everyone, Shaha. In this video, we will discuss about the conformation of monosubstituted cyclohexane and 1,2 some disubstituted cyclohexane. From the previous video, we will know that shear conformation of the cyclohexane is more stable than any other conformation. Like the boat conformation, twist boat conformation, chair conformation, half chair conformation, etc. And in this video we will discuss about the stability of the chair conformation is changes when we substitute hydrogen of a cyclohexane in the in with another substituents like alkyl group or another variable substituents. So let's get started. When we will substitute a methyl group, in this case this is a methyl group, we will substitute the methyl group with the hydrogen. We will substitute the methyl group in the place of hydrogen in cyclohexane of the chair conformation. There will be two choices will be present in our hand. That is one choice. If we we place the methyl group in the axial position, and methyl group, or we place the methyl group at the equatorial position, methyl group at the axial position and methyl group at the equatorial position. Now here you can see that there will be clash will be happen between the this hydrogen and this methyl group, and this hydrogen and this methyl group. So this is known as the 1,3 diaxial interaction of this axial of this conformation. But in this case you can see that there will be no clash is present in this equatorial conformation, where methyl will be present at the equatorial plane. So there will be ring flip will occur. Simply we first we will discuss about the ring flip. What is ring flip? Ring flip means this carbon, first we will numbering if this carbon is number 1, this carbon is number 2, this carbon is number 3, this carbon is number 4, this carbon is number 6. Now if the ring flip will occur, then this carbon becomes this carbon, that is there will be rotation in this direction, and this carbon will be this carbon, that is, and there will be rotation in this carbon, and the methyl group will be present at the equatorial position. So here we will see that when the ring flip of this conformation will occur, that is so the methyl group will be present at this equatorial position, and this carbon this carbon becomes 2, and this carbon becomes 1. This carbon becomes 1, and this carbon becomes 5, and this carbon becomes 4. Here you can see that this methyl group after the ring flip, this methyl group after the ring flip, this methyl group will be present in this carbon, that is carbon 1. This is carbon 1 and this is carbon 1, and the methyl group is present at this equatorial position, which is present in this axial position. So here we will see that this conformation where the methyl group is present at the equatorial position is more stable than the methyl group which is present at the axial position of the monosubstituted cyclohexane. And this is the torsional and this is the steric strain. Now we will consider about the torsional strain, and here we will consider the Newman projection of this conformation, that will be like this. Here you can see that there will be clash between this CH2 group and this methyl group in this conformation, and the clash between this methyl and hydrogen. But in this and here we will draw the Newman projection of this conformation. Then this is the Newman projection of this conformation, that is here the methyl group is present at the equatorial position. Here you can see that there will be clash will be present between the methyl and hydrogen and these two hydrogens. There will be two gauge interaction present between the two hydrogens and methyl, but you can see that this methyl is present anti to this CH2 group, and this is present at a far away, and this methyl group is present at the from the far away from this CH2 group. And we will see and we will know that the Gauss interaction, this is also a Gauss interaction, and that is the CH2 clash between the CH2 group and the CH3 group, which is much more than the Gauss interaction, that is Gauss interaction between the methyl group and the hydrogen group. So here we can see that the mode that is chair conformation. Now we will see that the chair conformation of the monosubstituted cyclohexane. Here the substitution is the methyl group is will be present more in the conformation where the methyl group is present in the equatorial position. So, and in the next in this structure we will substitute a hydrogen with a tert butyl group of the cyclohexane. In this case there will be in this case in the axial conformer where the tert butyl group is present at the axial position, and there will be 1,3 diaxial interaction is present between this hydrogen and this hydrogen. Okay, and we can say that the tert butyl group is a very big substituents considered than the hydrogen atom. So there will be the conformation. So this conformation becomes very unstable than this conformation where the tert butyl group is present at the equatorial position. And you can see that the 99.9% of the chair conformation of the monosubstituted cyclohexane where the substitution is tert butyl group is present in the equatorial is present in the is present in the 99% of the conformer, where the tert butyl group is present in the equatorial position. And in this case also, if we will consider the torsional strain of this conformer, there will be clash between this CH2 group and this CH2 and this tert butyl group, and the Gauss interaction is present in this CH2 group and tert butyl group, and this tert butyl group and this hydrogen atom. Okay, but in the case of where the tert butyl group is present at the where the tert butyl group is present at the equatorial position, here you can see that this tert butyl group is present at anti to this CH2 group, and this is and far away from this CH2 group. So so in this conformation there will be torsional strain will be present, and steric strain will be present. So this conformation where the tert butyl group is present at this axial position is more unstable than the equatorial than the conformation where the tert butyl group is present at this equatorial position, which is more stable. Here the equatorial conformer is more stable than this axial conformer. Okay, next so I will zoom this document. Here you can see that there will be delta G naught if the substituent is methyl in the cyclohexane, then there will be minus delta G naught is 1.7, that is and in the case of and in the case of where substituent is tert butyl group, there will be and minus delta G naught is 5.5, that is delta G naught here for the tert butyl group is minus 5.5 kilojoule per mole. That is in this case the delta G naught is minus 5.5 kilojoule per mole, which is the delta G naught, or the standard change in the standard Gibbs energy, which is the negative. Here you can see that this ring flip, in this case the ring flip has the delta G naught has the negative very large negative value, that is the delta S, that is the change in the entropy becomes more positive. Okay, so the reaction will be spontaneous, so the changes of this will be spontaneous. So this equatorial conformation is more stable than this, that is the axial conformer. And in this case you can see that the methyl group, when we will when we will make the size of the substituents will be bigger, then there will be delta G naught becomes more negative. That is this is CH, in this case you can see that CH3 group where the substituents is CH3 group as a substituents or methyl group it is known as. Yeah, in this case the change in the free energy between the axial conformer and the equatorial conformer is minus this is minus 1.7 kilojoule per mole. And when we changes the substituent with the primary carbon, like we CH to CH3, and this delta G value will be more negative, that is the reaction become more spontaneous. And when we make the substituents as the secondary carbon, that is the CHMe2, this value becomes more negative, that is this is the minus 2.1 kilocalorie per mole, minus 2.1 kilocalorie per mole. And in the case of tert butyl group, when we introduce the tert butyl group in with a substituent in the cyclohexane, there will be more negative value of the delta G naught, that is there will be that is the reaction, that is the change of the axial conformer into the equatorial conformer will be more spontaneous for the tert butyl group. And here you can see that the methyl, in this case the methyl group is present at the axial position. You can see that in this case the 1 degree carbon is present at the axial position, and in this case there will be substituents will be the 2 degree this is 2 degree substituent, 2 degree carbon, this is 1 degree carbon, and this is 3 degree carbon, and this is 3 degree carbon. And this is the methyl. And we can see that the energy of this conformer will be increases when we will make the substituent size of the substituents will be increases, that is energy of the cyclohexane when the substituent is methyl is much less than the 1 degree carbon, and the energy of that 1 degree carbon where the substituent is 1 degree carbon of the in the cyclohexane, in this case 2 degree in this case you can see that the energy increases when we increase the size of the substituents. In this case the tert butyl group is present present as a substituent in this cyclohexane. In the cyclohexane, so the energy will be increases when will be energy of the conformer for the tert butyl group as a substituent will be more than the 2 degree carbon, than the 1 degree carbon, than the methyl group. Okay, then now we will discuss about the conformation of the 1,2 disubstituted cyclohexane. Here we can see that there will be two conformation, two type of conformation is present in the 1,2 disubstituted cyclohexane. First we will discuss about the trans conformation, then we will consider the cis conformation of the 1,2 disubstituted cyclohexane. In this case we will in this case you can see that this methyl group is present at the above the plane, and this methyl group is present at the below the plane. that is this is a trans conformation. And in the trans conformation of a 1,2 disubstituted cyclohexane, um, there will be one methyl group is present at the axial position, and another methyl group is present at the axial position. This is known as a diaxial conformer. And there will be another conformation which is more stable than this diaxial conformer, where the methyl group is present where the both methyl group is present at the equatorial position, and this is known as the di-equatorial conformer, and this is known as a diaxial conformer. And in the trans conformation, two methyl group, whether the two methyl group is present at the axial conformation, and or the two methyl group is present at the equatorial point, both the methyl group will be present at the equatorial conformation. So here you can see that there will be this diaxial conformation will be less stable than this di-equatorial conformation, because there will be 1,3, because here 1,3 axial conform axial 1,3 diaxial interaction is present for this methyl group, and 1,3 diaxial conformation is present for this methyl group. So there will be two 1,3 diaxial or diaxial interaction will be present in this diaxial conformation. But in this case you can see that there will be no clash is present in this di-equatorial structure. So in the case of di-equatorial conformation, there will be less steric strain is present in the structure, but in the diaxial conformation there will be less steric strain is present in the structure. Now we will consider the Newman projection of this diaxial conformer, where here we will consider the torsional strain of the structure. Like this is the Newman projection of this diaxial conformation. Here you can see that there will be interaction present in the between the methyl group and this CH2 group. But in this case you can see that this methyl group is present, this methyl group is present and this methyl group is present anti to this structure, and you can see that this methyl group is present. There will be interaction between this CH2 group and this methyl group, and in this case you can see that there will be no interaction between this CH2 group and this CH2 group and this CH3 group, because this methyl group is present far away from this CH2 group, and this methyl group is present anti to this CH2 group. So there will be no torsional strain is present in this conformation, and this is the list, so according to this this di-equatorial conformation is more stable than this diaxial conformation. So let's move on to the cis conformation. Here you can, for the cis conformation of the 1,2 disubstituted cyclohexane, where here we use the substitution two substitution, both are the methyl groups, both are the methyl group. Here you can see that the both methyl groups are present in the plane, in the same plane, that is this methyl group is present in the above the plane and this methyl group is present below the plane, and this structure is similar to to this structure, that is one methyl group is present below the plane and one methyl group is, and another methyl group is present below the plane. So when we consider the shear conformation of the cis 1,2 dimethyl cis 1,2 dimethyl cyclohexane, there will be two conformation will be possible, that is one methyl group is present at the axial position in the and one methyl group and another methyl group is present at the equatorial position, and or we will and there will be ring flip will occur, ring flip, that is after the ring flip and this methyl group is becomes the axial becomes the axial position, this equatorial methyl group becomes the axial position and this methyl group in the equatorial position. Okay, so you can see that there will be no minimum change in the action in this shear conformation of this case, because in this case the one methyl group is present at the axial position, so there will be 1,3 diaxial interaction is present, but another methyl group is present at the equatorial position, and here you can see that in the equatorial methyl group there will be no steric strain is present. And when we will consider about this conformation, that is the where after the ring flip, where you can see that this structure is similar to this structure. Okay, so there in this case this methyl group, there will be 1,3 diaxial interaction is present between this methyl group and this hydrogen and this hydrogen or this hydrogen atoms, this hydrogen atom and this axial hydrogen atom and this axial hydrogen atom, but there will be no clash or steric strain is present in this equatorial methyl group. So these two conformation have thus equal energy, so there will be minimum this conformation have a minimum energy difference which is negligible, but in this but when we will consider the Newman projection of this conformation, that is here we will consider the torsional strain of this conformation, then first we will draw the torsion Newman projection of this conformation. Here you can see that there will be clash between this methyl group in this conformation, and this gauge interaction is present in this methyl group, that is this methyl group and this hydrogen atom, and the clash is present between this methyl group and this methyl group, that is the two there will be clash between the two methyl group and this methyl and hydrogen atom, and the clash is present in the between the this CH2 group and this methyl group. and when we will consider the Newman projection of this conformation, where you can see the same conformation, where here the CH2 group, there will be clash present between this methyl and CH2 group, clash present between the between this methyl group, between these two methyl group, and the Gauss interaction is present between this methyl group and this hydrogen atom. So the torsional strain and the steric strain will be of this will be same of these two conformations. So there will be minimum energy difference between these two conformation, and the two conformation of the two chair conformation of this cis cis 1,2 dimethyl cyclohexane will be present, that is this structure in the same amount and this structure in the same amount, and that is two conformation is present in the same that is two conformation is present in the same composition, that is 50 that is there will be 50-50 like 50-50, that is this conformation is present at the 50%, and this conformation there will be 50% of this conformation is present of the chair conformation. Okay, now we will consider the 1,2 disubstituted cyclohexane, where the here the two substituents are different, because here we will consider the tert butyl group and the methyl group, and this is a cis conformation. Here you can see that two groups, that is the tert butyl group and the methyl group, is present at the same plane. Here you can see that but in this case there will be large energy difference is present in this conformation when we flip the ring. Okay, that is in this conformation we have a choice if we will place the tert butyl group at the axial position and the methyl group at the equatorial position, and choice number 2 is methyl group is present at the axial position, and tert butyl group is present at the equatorial position. So you can see that there will be so you can know that there will be more clash between this between this tert butyl group and hydrogen, and this between this hydrogen between these two hydrogen, that is there will be more 1,3 diaxial interaction is present in this conformation than this conformation. So the you can see that there will be less clash is present between this methyl group and these two hydrogen. There will be less clashes between these two hydrogen, because the methyl group is much in the small size than the tert butyl group. So this conformation has a more steric strain. This conformation, here you can see that here the more steric strain is present than this conformation. So according to the steric strain, we will say that this conformation is more stable than this conformation. So this is more stable than this conformation. Okay. You can see that in the equilibrium, you can see that in the equilibrium, the more amount of this conformation of the chair conformation, more of this type of conformation of the chair conformation is present in the equilibrium, and this is present in the less amount, and this is present in the less amount, where the tert butyl group is present at the axial position and methyl group is present at the equatorial position. And now we will consider the torsional strain of these two structures. Here you can see that the Newman projection of this conformation, is this is the Newman projection of this conformation. Here you can see that there will be clash between these two groups, that is the Gauss interaction, and the Gauss interaction between this CH2 group and this bigger group, this bigger group, that is the tert butyl group, is present. But in this case you can see that there will no clash between this tert butyl group and this CH2 group and this CH2 group, because this CH2 group is present anti to the tert butyl group, and this CH2 group is far away from the this CH2 group is present far away from this tert butyl group. And there will be one interaction is present between this methyl group and CH2 and this CH2 group, which is the Gauss interaction, Here you can see that the tert butyl, there will be clash between this tert butyl group and the CH2 group is greater than the clash between this methyl group, which is lower in size, between this methyl group and this CH2 group. So the stability order of this conformation is much more than this conformation. So the stability of the order of this Newman projection of these two conformer is the same. So the stability of the conformer where the methyl group is present at the stability is more in the conformation where the methyl group is present at the axial position, and the equatorial and the tert butyl group is present at the equatorial position, than the conformation where the chair conformation, where the tert butyl group is present at the equatorial conformation and methyl group is present at the equatorial conformation. So in the next video we will discuss about the conformations of the 1,3 disubstituted cyclohexane and 1,4 disubstituted cyclohexane. And thanks for watching. If you like this content, then you can like this video. So thank you. Good day.